afternoon. Today I'm going to talk about CloudStack infrastructure monitoring with Grafana. Before that, quick show of hand who have heard about Grafana or any other monitoring tools. Okay. So what kind of monitoring tools are you kind of using right now? Are you using Grafana or any other like Elkstack or Elkstack? Okay. Zabbix. Okay. So I'm going to talk about Grafana integration because I found it was very useful in collecting the metrics and creating nice dashboards, so that I'm sending out alerts so that you won't be woken up in the middle of the night for a emergency issue like CPU is high, RAM is down, and instance is not deploying. Such kind of alerts. So quick intro about myself. I'm a QA engineer at ShareBlue. I've been involved with CloudStack since 13 years, and open source enthusiast, addicted to various podcasts and audiobooks. I frequently blog about CloudStack in my blog. So this is the quick agenda. I'm going to highlight why monitoring is important if you've got a good, if you have a cloud environment. What are the present monitoring challenges in CloudStack, and a review of existing tools and why I choose Grafana for my proof of concept kind of thing. The architecture diagram. I will give a demo of the dashboards that I've created for all the CloudStack-related infrastructure and the lessons that I learned. So why infrastructure matters? So currently, if you take any cloud, be it any public cloud or private cloud, most of them are multi-zone, multi-hypervisor, getting the metrics, data, logs from each of the services that these public cloud providers provide is very difficult. And you got auto-scaling, the workloads can scale and up and down pretty fast, and it's very difficult to identify the bottlenecks or failures that happen. So if you've got a good monitoring team, we can avoid such issues. So if you got a monitoring team and a good of dashboards, you can detect the failures quickly. So you must have some SLA and SLO agreements with your end users, and you can reduce the mean time to resolve the tickets. And we get valuable information for debugging an issue from the metrics that are available. So currently, if you take a look at CloudStack, the monitoring challenges are huge. If you take a look at the different API calls, you got metrics, hypervisor, host metrics called separately. There is usage metrics called separately. There is DB metrics and VM metrics, storage metrics, all are separate API calls. There is no single API call that you can get all the metrics in one go. And hypervisors have their own metrics, and it may not match with the CloudStack reported metrics. And storage, same thing applies to storage and networks. You may not get all the metrics in one place, and it may not match with the actual reported values from CloudStack. Basically, there is no unified dashboard that you can see all the metrics in one place. And there are a lot of challenges, like if you want to identify how much a per cluster is, per host is giving a metrics, we need to develop your own custom scripts to get the information and execute a particular API call to do that. And mostly CloudStack focuses on real-time operations, not long-term trends. There is no time series database that you can see from CloudStack. And also the storage part. We can't store much information like in the CloudStack DB that over time we can analyze the metrics and what happened. And it's always hard to visualize. If you're anybody fan of CloudStack logging mechanisms, will understand it's very hard to debug what is happening in the CloudStack infrastructure, be it agent logs or management server logs, or the router-based logs. So, and troubleshooting DB text-based logs is also very difficult right now. So, so I think if you have got a good dashboard, we can solve these challenges. These are the current monitoring tools that are available right now. So about 2 years back, I gave a talk on Elasticsearch and how we can integrate Elasticsearch with CloudStack. But it was not that dashboards generated by Kibana were not that much popular. So I thought I'll play around with Grafana and see what happens. But also I heard that Elasticsearch changed their license agreements. They moved from Apache license to other some which are not much familiar, but that caused some shift in the community, and there's an open search fork that got created from Elasticsearch. And if you see, the Zabbix and Agents have been there since forever. And if you see the bottom, like New Relics, Splunk, and these are SaaS-based monitoring tools. So you have to use their SaaS subscriptions to get the logs analyzed. So this is why I choose Grafana. It's very lightweight and modular architecture, and it has got massive plugin integration, and it solves my use case of generating a unified dashboard. I also heard that Grafana changed their license agreement since same as Elk, but it's not affecting for me right now, but we can take a look at it in the future. But there are still forks of Grafana, like OpenSearch happened. I came to know from CISO Cloud that there is Plutonia, so something that is a fork of Grafana if you want to maintain license agreements. Coming to Grafana stack overview. This is an open source platform for metrics, logs, and traces. You get the unified observability in a single pane of glass. You can correlate the data from hypervisors, management, and the API calls from CloudStack. So you need not jump across different SSH sessions to get based on logs. You can just ship the logs in one place to Grafana, and you can get the single view. So these are the key capabilities. It integrates with all kind of open source monitoring systems. It has got SLOs and SLI alerts based to all the alerting systems that are out there. It offers role-based access to the users. And it also offers LDAP support and API keys authentication so that the data is secure and there is no other security issues. So Grafana Labs has got many tools. So I'll be concentrating on these particular 3 tools for my POC. So first is Prometheus. You have heard of Prometheus, right? Okay. So Prometheus is well-known metric scaper. So every system that generates metrics, Prometheus can get those metrics and store it in its database. And Grafana Alloy. So previously, this Grafana Alloy tool was recently introduced about 4 or 5 months back. Previously, they were using Promptail, which used to ship the logs to the Grafana stack. Currently, they removed Promptail and they're switching to Alloy. So Alloy tool generally ships the logs from all the services and into Grafana. So Loki is another tool which collects the metrics and logs, which again integrates with the Grafana. So this is overall the architecture. So I got CloudStack, all the hypervisors that CloudStack is integrated with, and there is a Prometheus agent sitting on all the hypervisors, which exports the Prometheus data. So even CloudStack exports Prometheus data. And if you can see, for logging purpose, I'm using Grafana Alloy purpose. So logs of CloudStack or any system VMs, routers, host can be shipped to Grafana Alloy, and it stores in this Grafana Loki for the storing of the logs, and Grafana queries creates a dashboard for the logs. So you can see the logs in one dashboard. Similarly, KVM, there is a Prometheus export for KVM, VMware, XCP-ng, and it all ships the data to Prometheus server, and Grafana can natively query the Prometheus server. Similarly, there is a MySQL exporter also, but I am using the native integration for MySQL data source, so they can directly connect to the CloudStack database and get the relevant information. Or you can use, if you're facing some slow queries, or if you want to troubleshoot MySQL performance, you can use of MySQL Prometheus exporter to get that information. I'll go through each of the exporters and show you the dashboards, how they look. So this is the CloudStack Prometheus metrics. So CloudStack, we need to enable, to generate the Prometheus metrics from CloudStack, we need to enable the global settings, Prometheus, and give the Prometheus IP. And in the Prometheus server, we just need to give the path of the CloudStack IP to collect the metrics that CloudStack generates. And this is the sample metric that CloudStack metrics generates. This is like host count of total hosts that are online. So this is some sample dashboard that I generated from CloudStack metrics. Currently, their metrics are limited from the CloudStack Prometheus exporter, but we are keen on improving it with the help of community members. Similarly, for KVM, so we need to, there is a libvirt plugin which exports the Prometheus metrics from a KVM host. It's based on Go, and we need to install the plugin on the every KVM host that you want to get the metrics. And similarly, do a Prometheus configuration on the Prometheus server to get the metrics. And this is the sample libvirt KVM host metrics, Prometheus metrics. And this is one sample dashboard for a KVM hypervisor. Similarly, a dashboard for VMware. So the VMware has also got Prometheus metrics. I have tested with 6.7 and 7.0 versions. And I found these tools which does a good job of exporting the VMware metrics. And this, again, we're going to give a configuration in the Prometheus server. So you have one Prometheus server, and you give one configuration for each exporter. And so this is a sample VMware dashboard from the Prometheus metrics. Similarly, XCP-ng, there is a exporter for Prometheus for XCP-ng, and give a configuration file for Prometheus, and this is sample Zen server metrics. And this is a sample dashboard for Zen server metrics, XCP-ng and Zen server metrics. And coming to the interesting part of getting the logs. So this is a little bit complicated because it has got multiple steps. So first we need to install a shipping agent, that is the Alloy tool, on the CloudStack management server or the KVM host or the routers or system VMs. And we need to give this particular path. So we need to ask the shipping agent which log to track and ship it to the Loki server. So I just get the path. I want this particular log, and I want it to ship to the Loki server, and I give the Loki server's endpoint. So the logs, even it is log rotated, it keeps on shipping the data to the log server. And once the data is in Loki, we can ask Grafana to query the logs and show it in the dashboard. So this is a sample dashboard for CloudStack logs. Once the logs are in the CloudStack dashboard, you can quickly grab for any job number or error messages, which shows the entire stack messages. And finally, the dashboard for the MySQL data source from Grafana. So we need to create a read-only user for Grafana user in the MySQL database and give the authentications so that Grafana connect to the MySQL um, and get the data. So this is a sample that dashboard for that cloud database. So basically, I'm querying how many VMs are there for a particular user in a team or some. A simple SQL query, and we get the data displayed on nicely. And coming to the alerts part, since there is all this data, Prometheus metrics, and we can configure alerts. Suppose a metric, say, RAM threshold has crossed a RAM from the 4 GB or CPU has spiked. We can create an alert in Grafana and send it to the email alerts or PagerDuty or Slack. We can configure all in Grafana. Or you can configure in Prometheus also, but since this is UI based, so I found this integration better. So we can configure. There's no multiple touch points being they are offered by Grafana. Coming to the lessons learned, it took me a lot of trial and error to get this setup ready. So I would suggest start with a small. Don't integrate completely. Start with a simple Prometheus and get the metrics on Prometheus. Send it to Grafana. Then growing on, add the hypervisors and what are machines, then be it node exporters or what. And if you want more integration, you can go for Alloy. And use consistent namings, like the variables, like there are drop downs and filtering in the dashboards. You should use a naming convention early, and it can so that variables can be repeated across dashboards, and it will be easy to identify. So we can share the dashboard that you create can be shared in centralized location and can be given to access to your team. And you can create templates and embed it into a web page, and the logic can be used across all multiple dashboards also. Conclusion, I'll show the demo of the dashboards once again if you want. One sec. Okay. So this is the KVM dashboard, which is integrated with the KVM. So the Grafana dashboard has got a lot of community dashboards that are generated. So this is one of the community dashboards that I picked up. And we can see the network, storage, and VMs, CPU, and memory information. So coming to this logs, so we can view the logs live, or if you want 30 minutes, you can see the logs over here. So basically, this is management server. We can add multiple panels for each logs, or integrate in the same, so that you can correlate the log ID or job ID across all the logs. This is the Cloudstack. So Cloudstack Prometheus metrics. So we can select the host of each Cloudstack, KVM host, and we can get the memory, CPU usage, primary storage. So we can have nice drop downs and select the zones. This is the vCenter one. So we got all the EXI hosts and data stores. So there are multiple dashboards based on your use case trial and error. You can remove the add and remove the panels. So this is the MySQL. So so if you want to know how many VMs each person is using in a team, so you can just get the count from the database directly. This is the Zen server. same as the KVM network, storage, and collector size. Yeah, I think I covered all the dashboards, right? Concluding it, CloudStack has got a lot of metrics. It's just the challenge is that the visibility is not done properly. So I use Grafana to get it done, but with exporters and pipelines, it becomes a strong observability platform. Um, so Grafana Stack delivers it, and it's like open source, and we can divide dashboard metrics across tenants and get a good dashboard for your team. And so with these dashboards, like the root cause analysis will be faster, proactive alerts leads to less downtime, and teams can detect anomalies and forecast the result needs in real time. These are the references. I created a GitHub repo which does the steps and how do you configure a nice dashboard for Grafana using the steps, how to install all the tools in a VM and get the data. These are the Grafana IDs that I used, public IDs that I used in the dashboards.